Hey, glad you're still with us. Okay, so now we're going to talk about aerial navigation in this video. We're going to do an application problem which ties in some of our reference triangle and reference angle logic. We're still dealing with small, acute, right triangles, but we're also using these angles as rotations as well, right? So we may have a larger angle than between 0 and 90, but we can always create a smaller, acute reference triangle that will help us. One thing to note when we deal with aerial navigation, any planes flying, bearings, which means directions, they're always going to be given clockwise from north. So in this case, 0 is at north, and we rotate all the way around to get 360, which is different than the way we normally start. We normally start at 0 on the x-axis, and we rotate counterclockwise to get to 360. So just making sure you pay attention to the type of problem you're working on. So if we're talking about navigation, especially aerial navigation, we're going to start at north and rotate clockwise. So here we have an airplane which leaves an airport and they travel 300 miles in a direction of 300 degrees. We want to know how far north of the airport is the plane then, after it had traveled these 100 miles, and how far west. So we'll start by drawing a picture. We have north, obviously south, east, and west. In this situation, we are traveling a direction of 300. So as I said, we're going to have 0 degrees, 90 degrees, 180, 270, and 360. We travel clockwise from north. Therefore, my angle is going to end up over here in quadrant 2. So this is my 300 degrees. And then we draw that going out. That's the direction the plane is traveling, and that is 100 miles. So this allows us to draw our reference triangle. Remember, we always drop that vertical down or up to the x-axis. So I like to pull my reference triangle out of the picture. So what is the reference angle? We have gone to 300 degrees. We've gone just past 270. So in order to get to that 300, we have traveled 30 extra degrees. 300 minus 270 gives us that 30. I'm going to label my sides X and Y, X being horizontal, Y being vertical. And we're going to think about using a trig identity here. We need to know how far west and how far north we are from that initial location at the origin, which was our airport where we left from. So since we know that we've traveled 100 miles, I know one side of this triangle and I know two angles. I've got the acute 30 and the right angle. And I actually know all three angles because up here at the top, we know that's 60 degrees. So if we want to find X and Y, all we have to do are set up some trig identities. Don't forget SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Or we can remember y over r, x over r, y over x. All right, so sine of theta, or I'm sorry, sine of 30, because that's the angle we are now using. Sine of 30 is going to be y over 100. I can solve that, and I will have 100 Sine 30 equals y. Of course, I know what sine 30 is. Sine 30 is 1/2. So 100 times 1/2 gives me 50 miles for y. And cosine 30 is x over 100, or rather 100 cosine 30 equals x. Cosine 30 is root 3 over 2 equals x. So now we have that x is 50 root 3. So that means we are 50 miles north and 50 root 3 miles west from our initial location at the airport at the origin. And 50 root 3, that is roughly 87 miles. So that concludes this problem. We did an application problem involving aerial navigation, and we used the idea of a reference triangle to help us solve this. As always, email me if you have any questions.